everyone, my name is Faslul Rahman. Today I am going to discuss my Unit 5 mid-unit assignment for MHF4U. There are 3 questions in this assignment. Let's start by looking at the question number 1. Question number 1 asks us to determine an equation for the family of quadratic function with zeros minus 5 over 2, comma, minus 1, comma, 7 over 2, comma, and 3. Part A, write equation for two functions that belongs to this family. Step 1, identify the quadratic function. We start with the knowledge that we are dealing with a quadratic function, which is a polynomial of degree 4. Its general form is like this. Fx equal ax to the power 4 plus bx cubed plus cx squared plus dx plus e. Step 2, write the factor form. The problem provides us with the zeros, which means the x-intercepts, which are x equal minus 5 over 2, comma, x equal minus 1, comma, x equal 7 over 2, and x equal 3. Now we must write the factor form. Fx equal a within bracket x plus 5 over 2 within bracket x plus 1 within bracket x minus 7 over 2 within bracket x minus 3. It's important to notice that we used x plus 5 over 2 for x equal minus 5 over 2 because it's a negative value. And for x equal 3, we used x minus 3 because it's a positive value. Step 3, writing the equation in integers. Typically, we prefer to write equation with integers instead of fraction. We can do this by multiplying all the terms by a common denominator, which in this case is 2. So fx equal a within bracket 2 x plus 5 divided by 2 within bracket x plus 1 within bracket 2 x minus 7 divided by 2 within bracket x minus 3. So it will be like this. Fx equal a over 4 within bracket 2 x plus 5 within bracket x plus 1 within bracket 2 x minus 7 within bracket x minus 3. Now we have a family of quadratic equation. To create two functions from the family, we can choose different values of a. For a equal 4, fx equal 4 divided by 4, 2x plus 5, x plus 1, 2x minus 7, x minus 3. We must simplify it further. Fx equal to x plus 5, x plus 1, 2x minus 7, x minus 3. So the next one is for a equal minus 4. F equal minus 4 divided by 4 within bracket 2x plus 5 within bracket x plus 1 within bracket 2x minus 7 within bracket x minus 3. We must simplify it further. Fx equal minus within bracket 2x plus 5 within bracket x plus 1 within bracket 2x minus 7 within bracket x minus 3. Therefore, this gives us two distinct functions that belong to the same family of function. Here one has a positive a and the other has a negative a. So we have answered our question number 1, part A. Let's look at part B. Part B, determine an equation for the member of the family whose graph passes through the point minus 2, 25. Step 1, understand the problem. We are given that we need to find the equation for a member of quadratic function family whose graph passes through the point minus 2, 25. This means that coordinates of this point should satisfy the equation. Step 2, substitute the point. We have the point minus 2, 25. This means that x equal minus 2 and fx equal 25, or we can say y equal 25. Our goal is to determine the value of a that makes this point fit into the quadratic function family equation. Step 3, use the quadratic function family equation. The equation for the quadratic function family that we determined earlier is fx equal a over 4, 2x plus 5 within bracket x plus 1 within bracket 2x minus 7 within bracket x minus 3. Step 4, substitute the values and simplify the equation. If we simplify the equation, we will get a as minus 1.8181. So step 4, write the equation for the member of the family. Now that we have found the value of a, so we can use it to write the equation for the specific member of the family, of the quadratic function family. So it will be fx equal minus 1.8181 8181 within bracket 2x plus 5 within bracket x plus 1 within bracket 2x minus 7 within bracket x minus 3. So we have discussed question number 1, part B. Let's move on to the part C. Part C, sketch a graph of the functions in parts A and B. Let's take A equal 4. If A equal 4, fx equal 2x plus 5, x plus 1, 2x minus 7, x minus 3. Step 1, determine the degree. First, let's check the degree of the quadratic function. We see that it's a quadratic function in the question, which means the degree must be 4. Step 2, determine the leading coefficient. Next, we must identify the leading coefficient, which is 1, because A over 4 equals to 1. Step 3, determining the x-intercepts. The x-intercepts are the values of A where the function crosses the x-axis. These intercepts are directly given in the question. X equal minus 5 over 2, comma x equal minus 1, comma x equal 7 over 2, and x equal 3. Step 4, determining the y-intercept. To find y-intercept, we substitute x equals 0 into the function. If we substitute, we will get y equal 105. So the y-intercept is at 0, 105. Step 5, graphing the function. With the gathered information, we can sketch the graph. The leading coefficient is plus 1. So we can say A is greater than 0, which means the graph is an upward facing graph. Here we can see the graph is an upward facing graph. Since the degree is 4, we know that it will be a quadratic curve, which typically resembles a W shape. So here we can also see it represents a W shape. The x-intercepts are minus 5 over 2, 0, minus 1, 0, 7 over 2, 0, and 3, 0 are points where the curve crosses the x-axis. You can see the x-intercepts. The y-intercept is 0, 105, which is where the curve intersects the y-axis. We can see the y-intercepts. Below, we can see the graph. We can see the graph and the characteristics of the graph, which I have mentioned here. So this is our first graph. Let's look at the next graph. Now let's take A equal minus 4. If A equal minus 4, fx equal minus within bracket 2x plus 5 within bracket x plus 1 within bracket 2x minus 7 within bracket x minus 3. Step 1, determining the degree. The degree of the function is 4 as indicated in the expression. This is consistent with the definition of a quadratic function where the degree must be 4. Step 2, determining the leading coefficient. In this case, the leading coefficient is minus 1 due to the negative sign in front of the function. A negative leading coefficient means that the graph will be downward facing, resembling the letter M. Step 3, determining the x-intercepts. The x-intercepts are given in the equation and are the same as for the previous function. Here are the x-intercepts. Step 4, determining the y-intercept. To find y-intercept, we substitute x equals 0 into the function. If we substitute and simplify, we will get the answer as y equal minus 105. So the y-intercept is at 0, minus 105. Step 5, graphing the function. With the gathered information, we can sketch the graph. The leading coefficient is minus 1. So we can say x is less than 0, which means the graph is a downward facing graph. We can see here, since the degree is 4, we know that it will be a quadratic curve, which typically resembles an M shape. Here we can see the graph is looking like an M shape. The x-intercepts are here. The y-intercept is here. Below we can see the graph. I have discussed all the characteristics of the graph here. So let's move on to the third graph. Finally, let's take A equal minus 1.8181. So if A equal 1 minus 1.8181, fx equal minus 1.8181 within bracket 2x plus 5 within bracket x plus 1 within bracket 2x minus 7 within bracket x minus 3. Step 1, determining the degree. The degree of the function is indeed 4 as it is a quadratic function. Step 2, determining the leading coefficient. The leading coefficient is minus 1.8181, which is negative. A negative leading coefficient means that the graph will be downward facing and will resemble the letter M. Step 3, determining the x-intercepts. The x-intercepts are provided in the question. X equal minus 5 over 2, x equal minus 1, x equal 7 over 2, and x equal 3. Step 4, determining the y-intercept. To find the y-intercept, substitute x equal to 0 into the equation. If we substitute, we will get the value y equal as minus 190. So the y-intercept is at 0, minus 190. Graph characteristics. Since the leading coefficient is negative, the graph is a downward facing graph, resembles the letter M. So it is facing downward. The x-intercepts are the points where the graph crosses the x-axis. The y-intercepts is at 0, minus 190. Here are the x-intercepts. Here is the y-intercept. So far we have looked all the parts of the question number 1. Let's move on to the question number 2. Question number 2. The distance d in kilometers traveled by a plane after t hours can be represented by d within bracket t equal minus 4t cubed plus 40t squared plus 500t. How long does the plane take to fly 4,088 kilometers? Step 1, setting up the equation. The distance traveled by the plane after t hours is given by the equation d within bracket t equal minus 4t cubed plus 40t squared plus 500t. We are looking for the time it takes for the plane to fly 4,088 kilometers. So we want to find the value of t when dt equal 4,088 kilometers. Step 2, simplifying the equation. We simplify the equation by dividing all terms by 4 to make it more manageable. So 4,088 kilometers divided by 4,000, 1,022 kilometers. So here minus t cubed plus 10t squared plus 125t. Step 3, setting up a cubic equation. We set up a cubic equation by moving all terms to the left side. So it will be t cubed minus 10t squared minus 125t plus 1022 kilometers equal to 0. So this equation resembles a cubic polynomial in the form of ax cubed plus bx squared plus cx plus d equal fx. Here fx is equal to 0. So step 4, using the factor theorem. Find the factors of this equation. We use the factor theorem, which means we want to find the values of t that make this equation equal to 0. So we consider the factors of 1,022 kilometers. So they are 1, 2, and 7 and apply trial and error. Step 5, testing factors. We test each factor in the equation. So if we test t equal 1, it will become 888 kilometers. So T1 is not a factor. If we test T2, it will become 740 kilometers. So T2 is also not a factor. So let's move on to t equals 7. So here it will become minus 1022 kilometer plus 1022 kilometer equal to 0. We find that t equals 7 is a factor of the equation. Step 6, long division. To find the remaining factors, we perform long division. After performing long division, we will get the result as t squared minus 3t minus 146. Step 7, factorizing. After long division, we arrive at a new quadratic equation, t squared minus 3t minus 146 equal to 0. Now we can use a quadratic formula to find the two possible values for t. We use and simplify, we will get two values as t equal 13.6758 or t equal minus 10.6758. Step 8, checking the value range and the final answer. The question states that t must be between 0 and 10. Since both of these values are outside the range, both of the values means t equal 13.6758 and t equal minus 10.6758. Since both of these values are outside the value range, we can say that the plane takes 7 hours to fly for 1088 kilometers. So we have discussed question number 2. Let's move on to the final question, which is question number 3. So question number 3 is write an equation for a rational function whose graph has all of the indicated features. X-intercept of -4, y-intercept of -2, vertical asymptote with equation x equals 2, horizontal asymptote with equation y equal 1. So step 1, understanding rational function. Before we dive into the problem, it's important to understand what a rational function is. A rational function is a function that can be expressed as a fraction where both the numerator and the denominator are polynomials. In this context, a polynomial is an expression consisting of variables and constants combined using addition, subtraction, multiplication, and division. However, the denominator cannot be equal to 0, as this would result in an undefined function. Step 2, analyzing the given features. The question provides several key features of the desired rational function. It says x-intercept at -4, y-intercept at -2, vertical asymptote at x equal 2, horizontal asymptote at y equal 1. Step 3, writing the rational function. First one is x-intercept. The x-intercept occurs when the function crosses the x-axis, meaning the value of the function is 0, or we can say y equals 0. We use this information to write the x-intercept equation. In this case, we have x-intercept at -4, which leads us to the equation f with fx equal within bracket x plus 4. Second one is y-intercept. Similarly, the y-intercept happens when the function crosses the y-axis. We set x to 0, or we can say x equals 0 to find the y-intercept. Given that the y-intercept is -2, we have f0 equal -2, which is fx equal -2. Third one is vertical asymptote. The vertical asymptote represents the values of x where the denominator of the rational function equals to 0. So in our case, we have x -2 equal to 0, which results in the vertical asymptote at x equals 0. Fourth one is horizontal asymptote. Fourth one is horizontal asymptote. The horizontal asymptote gives us insight into the behavior of the function as x approaches positive or negative infinity. Here we are told that there is a horizontal asymptote at y equal 1. Now we put it all together, we have fx equal x plus 4 as the result of the x-intercept feature, and we also know fx equal -2 as the result of the y-intercept feature. We also know that there is vertical asymptote at x equal 2, which means that within bracket x -2 is in the denominator. So our rational function starts to take shape as fx equal within bracket x minus 4 divided by within bracket x minus 2 within bracket x plus 4 divided by within bracket x minus 2. Now we need to consider the horizontal asymptote at y equal 1. This implies that x approaches infinity, the value of the function approaches 1. So we can say that the degree of the numerator and the denominator is the same, which is both 1. So this implies that the horizontal asymptote is y equal a over b, where a and b are the leading coefficients of the numerator and the denominator respectively. So in this case, a equal 1 and b equal 1, resulting in fx equal within bracket x plus 4 divided by within bracket x minus 2. This rational function satisfies all the given features. Therefore, we can say that the above equation represents a rational function that matches all the indicated features. So I have discussed all the 3 questions. This is my end of the assignment. So thank you for watching. Cheers.